So, good evening. I'm Ishani. I'm from third year BTech CSC. So, now let's learn about a DSC experiment, that is decision tree classification. So, in the first step, we import all the libraries. Pandas, that is main library for reading and manipulating tabular data. NumPy as NP, its numerical array and helper functions. Import matplotlib as pyplot as PLT is used for graphs, visualizations. Import Seaborn as SNS. It is convenience plotting visual or improvements. It is optional. And the next one is used for functional to split dataset into training and testing sets. And the decision tree classifier plot trees, the decision tree model, and the plotter helper. sklearn.metrics import is imports the evaluation metrics we need. So we need confusion matrix, accuracy score, recall score, precision score, FN score, ROC score, and confusion matrix display. It helps for plotting confusion matrix. So the next step is to load the dataset and select the features. So read CSV file into data frame named data. Replace data.csv with your actual file name. Here my file name is cancer.csv. And features are a list of 10 columns you want to use as independent variables. So x is equal to data features are create X data frame that contains only chosen feature columns, and Y is equal to DF diagnosis. It sets Y as the target column, and diagnosis column containing M and B values. So the next one is to encode the target, that is categorical to numeric. So from sklearn processing import, we import helper to convert text labels into integers. So L is equal to label encoder is create a label encoder instance, and later matrix assume positive class is 1. Here 1 corresponds to M, that is malignant, so which is what we want. So it correctly identifies the malignant cases. And the next one is to split the data, that is training and testing. 75% for training and 25% for testing. Train test splits x and y into training and testing sets. So test is 0.25, that is 25% of data is reserved for testing, and 75% is used for training as required. Random state is equal to 42. It is nothing but it sets the PRNG seed for reproducibility. Any fixed integer will do. And stratify is equal to y is it is very important, and it ensures the class proportions B versus M are preserved in both train and test sets. This prevent accidental class and imbalance between splits. And train decision tree with entropy is nothing but it uses information like a gain to choose splits instead of default. And random state is equal to 42 again is responsible for reproducible tree building where randomness exists. So decision tree are scale invariant. They do not require features, and they do not require features like min, max, or standardization. That's why the exercise is said don't use feature scaling. So if you need predicted probabilities like ROC and AUC, use model that predict probability X test to get probability of class 1. And the next one is performance metrics of a confusion matrix, accuracy, precision, recall, and specificity, F1 and ROC or AUC. And CM. So TN, FP, FN, TP are CM level. Unpack the confusion matrix entries uh, into named variables. TP is true positive, TN is true negative, FP is false positive, and FN is false negative. TN is predicted 1 and true 1, so malignant correctly detected, and it gives the output like malignant correctly detected. TN is true negative, it predicts 0 and true 0. Benign correctly detected, it prints benign correctly detected. And false positive predict 1 but true 0, it prints benign mislabeled malignant. And the next one is predicted 0 but true 1, it prints malignant mixed. Important clinically. Accuracy is overall function of correct predictions like TP plus TN by total. And precision is predicted positives and how many were correct. So the formula is TP divided by TP plus FP. And this recall is the formula is true positive plus false negative. How many actual positives were found? Sensitivity. Specificity is Tn divided by Tn plus Fp, that is how many actual negatives were correctly identified. And F1 squared is the harmonic mean of precision and recall. So if the classifier never predicts the positive class, so precision score or recall score can raise warnings or be undefined. So plot ROC curve. Create a new plot. The first step is to create a new plot with the specified size and plot the ROC curve, that is x-axis is false positive rate and y-axis is true positive rate. So x dot label and plot dot y label is nothing but axis labels and their titles, and legend is show the legend with AUC, and PLT dot show is render the plot. And now we have to display the constructed decision tree. So the first step is to reserve a large figure so the tree is readable, and it draws the tree structure. Label each split with feature name, and labels benign, the class names benign and malignant labels for class 0 and class 1. So the important is ensure this order matches your label. Encoding, if LE dot classes is B or M, then class name is benign and malignant maps correctly. Filled is equal to true. It color nodes by predicted class. So intensity indicates the purity. Font size is equal to 10 is text size of the tree labels, and PLT dot show is visualize the thing. Thank you.